Aluminium rods. Today I found this old Stirling engine here in my garage. I built it 10 years ago and it never ran. I'm not sure what went wrong there. Maybe I did some wrong calculation. Probably the friction was too big. I took two old pistons from Trabant, two-stroke engine, and the what's the name? The cylinder sleeves. I put it on the lathe, so I built the cylinder. I built myself. Only the piston is from a real engine. Everything else I built myself. So the housing, the rods, I built myself. Oh, the crank. The crank is from a bicycle engine. It's from a bicycle engine like this one. But the rest I built myself. It never ran. I want to find out what's wrong with it. Today I want to recheck. Both sides are connected with this piece here. Inside I have some steel wool as steel wool. What is the name? As like a buffer, like a heat buffer in between. This sits on here. But first I want to mount it to the wood. Now it's fixed, so we can start our tests. The next step will be to put this piece on, and we have to make a sealing. Let's put this on. Okay, this side is done. It's not made for this high temperatures, but I hope when it burns, it will seal this area. Okay, we put this on. Okay, we have compression. Oh, I forgot the cover. The cover for the case. Yeah, let's better put that on as well. Okay, this one won't fit, but we will try without. Okay, first I want to check, just in case this one won't run again, and it's highly likely that it won't run again. I want to see how fast I can turn it just with the drilling machine. Therefore I put some tape on it, and I will measure the RPM in cold, and also I will then, right now we have 8 degrees Celsius or 6 degrees Celsius, 5.6 degrees Celsius here, and then I will heat it with the propane torch, and we will check the RPM again by the drill. So let's try first gear, if we can make it run, and also check the RPM. $290, 289.1. Good. Now I will heat it. Now I will heat it and then check if it's not running from alone, or yeah, if it's not running, then I will check the rotational speed again. If I run faster when it's heated, then I know the principle is working, but my friction is too high. Yeah, let's check. Okay, now I want to make it run. Probably it won't run because 10 years ago it was also not running. It's very hard right now. Let's see if it gets easier if I heat it up. Therefore I want to protect my cold side from the heat. With this one here. Check. And maybe like this. Yeah, like this. Then we have the propane on here. We have this. We measure it when cold. I can turn it with the drill. I can turn it 289 rotations. Let's check if it gets faster if I heat it up. Yes. Okay, we have 65 degrees Celsius, 160, 206, 'Aluminium was melting. 300, around 300. 400, 400. 450. Oh, it's coming. Need more heat. Okay, we have 460 degrees on top. Right now I can turn it very easily, but it won't run. So I want to try with the drill and check the rotational speed. Okay, 360. 360. It's faster. It's faster than before, so the engine works, just the friction is too high. That's great news, actually. We have around 170 degrees on the cylinder wall. And 475 on top. Oh. It was nearly running. Wow. You saw? Great. Let's try to get it hotter. 517 on top. We need more. $534. Let's try again. $530. More is not possible, looks like. But it was nearly working. You see? Wow! That's great news. Okay, enough. But we could see that when it's hot, it was turning faster than cold with the drill. And also I can feel it by hand. Friction is too high, but it was nearly running, I think. Yeah. Still 430 degree. I think the piston rings, maybe the friction is too big on the piston rings. I can't remember what tolerance I chose. I think I made the sleeves 400s or 500s bigger than the nominal. Yeah, I think I made them the same size as the original motor from the two-stroke engine from the Trabant. But maybe the volume is not big enough for my buffer, for my heat buffer. Also, I can't remember the theory from this motor anymore. It's 10 years ago. I was very interested in that, and yeah, but I don't remember really how this thing is working. Oh, my heat shield already melted here. Okay, in the end it was not running. I think it was nearly running. I think I saw one stroke it made by itself, so it was nearly running. I think the friction is too high on the piston rings to my cylinder walls. Yeah, that's actually its kind of success. And 10 years ago I remembered I wanted to make it run with a natural heat source powered by this giant lens. It's a big TV lens, and I wanted to power it with by the sun, and this was supposed to be the source or the magnifying lens. I can remember I melted some stone with it, just with the sun, so it's quite powerful. Not sure if it gets the motor this hot, like the propane, but this was the plan. Yeah, why? I remember, yeah, originally I built this motor just to check my invention. I had an invention for the Stirling motor. It's not in here, but I wanted to improve the efficiency of Stirling engines. I had an additional piece which I wanted to put in, but I never built it because this was never running, and shortly after that I had other projects. But I remember, maybe I can do it this summer with the lens, and yeah, maybe I can optimize it. Or if any of you has an idea why this was not running, I think it was nearly running, but yeah, maybe something to improve. Maybe you have more what's the name? More experience with this, or maybe this part here. What was the name? Heat exchanger. Heat exchanger, maybe. Yeah, maybe heat exchanger. Maybe this part is too small, or I have the wrong material in it. I put some. There is steel wool inside. I remember I also did some calculations how much I should put in. I'm not sure. Maybe it's the wrong size. Anyhow, it was nearly running, and actually it would run, but the friction is too high. We saw already the efficiency coefficient or the rotational speed improved, but yeah, I call it a success. I liked it. Yeah, you see right now it's very hard again to even turn it. Before it was more easy. So, success.